So in the meantime, we'll go back to Lily and get another question answered.
Okie dokie, we'll do this one that asks, what is the difference between a compound and a molecule?
Cool. All right, I'm going to pull up two pictures here. Sciencey question. Okay, so this is one of those situations where, so a compound is always going to be a molecule, but a molecule is not always going to be a compound. It often is, but it's not always going to be. So I'm going to pull up two examples of molecules, one of which is a compound, and the other of which is not a compound. So let's take a look here. Let's do these two. Okay, if we could jump to my screen. So what you're looking at here is a graphical representation of a water molecule. Not a perfect one, but so water's chemical formula is H2O, meaning two hydrogens connected to one oxygen. So the red ball here is supposed to represent an atom of oxygen, and the two white balls should represent the atoms of hydrogen. Now this is both a molecule and a compound, and here's why. A molecule is going to be anytime two atoms are bonded together, and in this case we have three atoms bonded together. It's also a compound because we have more than one element mixed in. So in this case we have two hydrogens and one oxygen hooked together. Hydrogen and oxygen are not the same element, and so this is therefore a compound. Compound being sort of like a mix of more than one thing, two different things put together. Now let's take a look at a molecule that's not a compound. So this is a graphical representation of an oxygen molecule. Oxygen molecules are all around us at all times. About 25% of the air around us here on the Earth is made up of these little guys, and an oxygen molecule is two oxygen atoms bonded together. And maybe you can't see the bond here, I could switch. Another way to represent it graphically would be like this. So you can see these little poles in the middle are supposed to represent the bond. So this is a molecule because we have two atoms bonded together, but it's not a compound because both of the atoms are oxygen. So anytime you have just a single element bonded to itself, you do not have a compound, you have just an elemental molecule. Whereas if you have, once again, something like water or sugar, which is carbon, hydrogen, and oxygen, or methane, which is carbon and hydrogen, or salt, which is sodium and chloride, anytime there's a mix of more than one element and those atoms are bonded together, you're going to have a compound. But even like a diamond is just pure carbon. A pure diamond is just pure carbon arranged in sort of a perfect way. So even though there's lots and lots of carbon bonded together in a diamond, it's just carbon. So it's a molecule, but it's not a compound.
And you can have a really, really large molecule, like a diamond?
Like a diamond, yeah. Or a buckyball, or a carbon nanotube, or graphite in your pencil. Graphite in your pencil is pure carbon. And like when you draw all over the paper, you're just drawing carbon atoms together that are bonded in this really kind of perfect way. And that's not a compound, it's just a molecule.
That's interesting.
Yeah. Just again, sort of a language thing, sort of a question of just, you got to kind of know what it is. There are clues in the words, but this is just sort of, in some ways it feels like memorization.
Yeah.